Hello, and welcome to my Mechatronics final project for the University of Wyoming. So this project uses an Arduino Uno board. Now Arduino actually open sourced all of the designs for their hardware, so this is a knockoff. As you can see the brand name right there, it's an smraza. But it's the same thing as an Arduino Uno, so it will work for this project. Now this project actually uses 2 inputs and 3 outputs. Technically one of the components is both an input and an output, but I'll get to that. So here's one of the inputs, this little push button right here. These 2 LEDs are an output. This device, this component right here, is an ultrasonic proximity sensor. And this is a stepper motor. This is an output. Okay. Now, if you take a look under there, it might be a little hard to see because it's under the shadow of the breadboard. But under the breadboard is a stepper motor driver module. That is needed because the stepper motor, in order to function, requires more current than the Arduino board can provide it. So it has to have more current provided to it by the driver module. As you can see, the stepper motor is held pretty solidly in place by these Lego elements. We're just going to cover that right up. And this gear right here, this was very fortuitous because this gear fits very snugly over the drive shaft of the stepper motor. And that gear actually is going to mesh with this gear rack that's on the bottom of the compartment. Now the compartment has rails here and here that guide it along this track that you can see here in the device. And when I put the compartment in, the gear rail will mesh with the gear on the stepper motor, and the rails will fit snugly into those tracks. Let's go ahead and cover up the rest of this side. Put the lid on. There we go. And now we're going to cover up this side with some Lego elements. And put that on. And that. And then this unit will fit right there. This clear Lego dome is going to fit right into that round hole, and it'll just sit in there. That is to provide a viewing window for the LEDs. In this little device right here is the push button. I used a round plate here, a round tile. It has a flat surface so that that can interface with the push button that's on the breadboard. And it's built so that it just drops in there and rests right on top of the push button. And there it is, and it looks pretty cool. It looks like a Star Wars building. Pretty disguised. So the way this works is when you push the white push button, the proximity sensor that I showed you earlier sends out a ping that bounces off the back side of the compartment. And the amount of time that the ping takes to travel back to the sensor tells the sensor how far away from the sensor the surface is. In this case, the surface is the back side of the compartment. So this device is programmed so that when the compartment is closed, or in other words, the distance from the sensor to the back of the compartment is within a certain distance, it runs a program to tell the compartment to open. And when the compartment is already open, in other words, the proximity sensor senses that it's above a certain distance, it will run a program to close the compartment. Now notice when I do this that the compartment in its range of motion actually slows down at the end. I wanted that effect to simulate modern kitchen drawers, where if you swing them closed, they have kind of a damping effect at the end. So I'm going to demonstrate that now. Also notice that when the compartment is opening, the green LED lights up to indicate go or whatever. And when the compartment is closing, the red LED should light up. So let's try it. Cool. Now let's press the button to close it. And there you go. That is my Mechatronics project. I hope you enjoyed, and I'll see you later.